Welcome to this video. My name is Darshan M.KATGERI. I am working with Jain College of Engineering, Belgavi. In this video, we will be solving a few basic problems on isometric projections. Let us go through the first problem, wherein we are asked to draw an isometric projection. So take note, we have been asked to draw the isometric projection of a hemisphere of 50 diameter. So sometimes in this isometric projection, the problem will be given in the form of a definition. That means the orthographic views are not given. And in some of the problems, the orthographic views will be given and we will be asked to draw the isometric projection. So in this case, this simple statement is given, that is to draw the isometric projections of a hemisphere of 50 diameter. So let us see how to go about this problem. So in this view, you can see that the top view of a hemisphere is a circle, and if you see the front view, it will be like this. It will be like this. So this is the front view. It is like a half circle, and the top view is this complete circle which is shown here. Notice that this height, the height of the axis in the front view will be 25 millimeters. Okay, and that will not be specified in case of this hemisphere, because it will be half of the diameter. Diameter is 50 so the axis will be 25 millimeters. So let us move on. So to start with, we will draw one horizontal line, and we will select a convenient point, and from that point we will draw one line at 30 degrees as shown here. And from the same point we will draw another line at 30 degrees in this direction. That line also will be at 30 degrees. And we will use the box approach, wherein this hemisphere will be imagined to be enclosed in a box. So you can see the top view of the box here. So you can see the top view of the box is shown here in these blue lines. So what we have to do is, we have to first draw the box, and on the top surface of the box we will be drawing this circle, which will be drawn by 4 center method. Okay. So let us move on with this. Now you take notice that this is a square. So this side here is 50 This side will also be 50 because it is a square, and this is a circle, and it is enclosed in a box. The box is a square box like this, right? So all the dimensions are 50 millimeters here. So we have to measure this on 50 this 50 millimeter on the isometric scale. That is, you have to first draw the isometric scale, and you should mark 50 on the true scale, and then you should draw one vertical line to the horizontal line, that is the base, and it will cut the isometric scale at some point. You should take that particular length. So that length is the isometric length. So, or that can be obtained by multiplying 50 by the factor 0.81649, and thus from this particular point you can cut an arc. The length of this will be 50 multiplied by 0.81649. Similarly, we have to cut an arc on this side also. Notice that it is a square, so all the lengths of this square that we are going to draw here, all the lengths will be same or equal. So once we get this arc here, once we get this arc here, and this arc here. Then take the compass and mark these two arcs here. So all of these lengths will be same. Okay? So using a compass, you have to take isometric 50. You should keep compass here and mark an arc here and an arc here, and from here you mark this particular arc, and from this point you can mark this particular arc, so you will get this point. In case it is in case of a square, you see this point and this point, they will be exactly one above the other, so that should be noted. Then this line, the length of this line is isometric 25, because the axis here, the axis is going to be here. So the length of the axis is 25. So this length from this point to this point is 25, which is half of the diameter. So each of these lines, they will be isometric 25. So once you get this, then you join all the points here and you obtain the box. This is a very simple procedure. Once you obtain the box, on this top surface of this box, we have to draw this particular circle, for which we have to use the 4 center method. In this method, you take the midpoint of say this particular line, you take the midpoint of this line and join it to this corner of the box. Similarly, you take the midpoint of this line and join it to this corner of the box. Then you consider this particular edge, this edge here, and you take the midpoint of that and you join it to the corner, and then you can take this particular edge and join it to this corner. Notice that we get V here and A here. Just make things more clear. So once we have this, what we can do is, now to draw this, we have to take this as the center. So the first arc that we are going to draw, we are taking this as the center and this as the radius, and we are drawing this particular arc starting from here to here. So this is one arc that we will get, first one. Next, you take this as the center and you measure this much, that is this particular length, and then you have to draw this part of the arc. Okay. Next, you can take this as the center, this particular as the center, and this much as the radius, and draw this arc here, and then this will be the center and this much will be the radius, and you have to draw this particular arc here. So this is how this isometric projection of this circle is obtained here. Next, to draw this, you have to take the actual radius of 25. So from this point, you can consider this point here. You can consider this much as the radius, this much length. I will change the color so that it will be more visible. You can take this much for drawing this, and from here you can draw this particular arc like this. So this is the drawing. This is how we have to obtain the hemisphere. And you can see that A, B, C, D are named. A, B, C, D are named. And this is the 4 center method. You can see that this was the first center, then second center, third center, and fourth center. So altogether there are 4 centers. So this method of obtaining this circle in isometric projection is called as the 4-center method, and this has to be the true length. This has to be the true length of this is the second problem, wherein we have to draw the isometric projection of horizontal cylinder of base diameter 50 and axis length 60 millimeters. So let us go to the software and see. First of all, we will go back a little bit. We will go back here. And we will try to draw this particular figure in the software. So to start with, we have to start by drawing a horizontal line. Then you select a convenient point. In this case, I will select the end point, the midpoint of the line, and I will draw one line. The length of this line is going to be this much. That is the isometric 50. So this length has to be isometric 50. But as explained in one of the videos, we are going to draw the isometric view, and then we are going to reduce all the lengths at once. So right now I will be drawing the isometric view. That means I have to draw it without multiplying by the factor 0.81649. That means this length will be actually 50 mm only. And then I have to place it at 30 degrees. So the angle will be 30 degrees. Next I will draw another line. I will just zoom in a little bit. Yes, like this. I will draw another line whose length will be 50, and angle in this case is going to be 150, like this. So 150 is basically this particular angle. So this angle is 30 degrees. Let us see the angles. This is 30 degrees, and this also should be 30 degrees. So once we get this, now because it is a square, these lengths that we are going to draw will be same. So you can select move command as explained in the previous videos. So you can take this and place it here, and similarly I want to move this. So you can go to move command, put on copy, and move it from this point to this point. So thus we have obtained the base of the box that we have enclosed our solid in. Next we have to draw the height. The height is 25. So this length also should be 25. So once I have drawn this much, the angle here is 90 degrees. So you input the angle also. So once I have drawn this much, then I will select all of this, and again I will go to move command, put on copy, and from this point to this point, if I move, I will get the top surface very easily. But in case of manual drawing, you have to actually draw each of the heights here, the lateral edges, and then you have to mark isometric 25, and then you should draw this particular top face. But we are working in a software, so the process becomes a lot easier in this case. So I will take a move command again, and I will move it from this point to this point and to this point. So these edges are not required, so we can cut these edges. So I will cut both these edges. So this is the top face that we wanted. In this or on this surface, we have to now draw this particular circle by using 4-center method, for which what we will do is we will select a line, we will change the thickness of the line, and I will select the midpoint of this. In case midpoint is off, you can go here and select this, activate this. In fact, select the midpoint and join it to the corner here, and similarly join this corner to the midpoint of this particular edge. And then this line, select the midpoint of this and join it to this corner here, and similarly at the same time you can join the midpoint of this particular edge. Now we have to draw this arc, this particular arc here. To draw this, I will select arc, that is arc by center point, and I will change the thickness of this. I want 0.5 thickness, and this is the center, and this much is the radius of the arc. So I will select the arc and I will draw this arc like this. Similarly, I will select this and I will draw this particular arc like this here, from this point to this point. So we have drawn two arcs here. Those two arcs are nothing but this particular arc and this particular arc. And now we have to draw these arcs here, and that is this arc and this arc, for which this has to be the center. So again select the same command, and now select this as the center and this much as the radius. Once you get this, if this happens, then what you can do is you can merely go to circle option and draw this arc, and then you can go to trim, and you can trim the unwanted parts of the circle, so you will still get the same result. You can do the same in this case also, but let's try by doing an arc here. So from this point to this point the arc has worked. So this is the circle that we wanted. Now we have to draw the boundary of this hemisphere, for which I will join this corner to this corner, and I can join this corner to this corner to get the center. Let us keep these lines very light. So we will select these lines and we will make them very light. Again we will go to arc by center point and we will select this, and we have to actually draw tangential to this, but for an introductory course you can consider this center point and you can draw an arc. You can see that you will get a figure somewhat like this. So this is what is required. All of this, that is the box, is drawn to get this. So all of this should be in fact made very light. So you will see that this is the hemisphere that we wanted. Again take note that we have not drawn the orthographic views, because in this case the orthographic views are not required, because we know all the dimensions that are required to draw this particular view. So that this isometric projection. So this is the complete solution. Wherever required, we have to draw these orthographic views. So in this case it was not required, so we did not draw the orthographic views. So this is the complete solution. There is a small correction in this drawing that we have drawn. Before drawing this arc, we have already drawn it, so let us delete this or cut this. Before drawing that arc, all of this has to be multiplied by a factor of 0.81649. We had to do it before we drew the arc, so we will do it now. That is, I will select all of this and then we will go to this particular option. Here we have scale, and in scale we have to give the factor of 0.81649, and we don't want the original one, that is the view, but we want the isometric projection. So we will multiplied by a factor of 0.81649, and we will keep this. Okay. Now you will notice that this length is 40.82. We will just dimension it for time being. Is 40.82. That is, if we multiply 50 multiplied by 0.81649 is ultimately 40.82. Okay, and that is what we have got. Okay, so we have to convert it before drawing the arc. So we have done that. Now we will go to arc by a center point, and we will take this as the center, and this can be taken as the radius, and then we can draw this arc. So this is the final solution here. So if I zoom out, you can see this is the final solution. Thank you.